Hey folks, just finishing getting set up here. We'll get started in just a second. Go ahead and get your questions. I'm just sorry if there's a question in there. We do have a question regarding some of the stats stuff. I don't want to. I want to take those outside of study hall for now. If you DM me about that, apologies for that. We can go over that at a different time. If you have Python, if anybody's got questions regarding Python, feel free to put those in, and I'll be happy to take those in study hall. Just provide a link to the problem so I can find it quickly. Yeah, sometimes like a problem will show up in sort of multiple incarnations. So if you describe it, I might like try to navigate to the wrong place, and then it's just kind of a not a good use of time. So if you provide a link, I'll be able to find it quickly and take it as soon as possible. Yeah, so just a quick reminder that everybody's welcome to do that. Go ahead and just post in there, and we will go from there. I'm not seeing anything at the moment, so let me just check on this. And we'll get started going through the material. But yeah, just to be extra clear about this, if you have any questions regarding Python, you can just put them in anytime. Even though I'm going to be going through the material, it wouldn't be an interruption if you want to just put them in, and I'll get to it as soon as I can. Cool. Oh, all right. Looks like we got one. We got a taker. Okay. There's that. Challenge 2, removing dictionary keys. Okay. Looks like we've got some code incoming for this one as well, which I'll go ahead and give a troubleshoot to. Okay. Let's see if I can copy that. There we go. And paste it. Okay. And this is, again, yeah, challenge 2. Okay, good. Removing dictionary keys. All right. So write a function called try to remove. Cool. Takes 3 arguments. Test dict, a dictionary. Test key, a key that may or may not be in the dictionary. Pop, a parameter named pop, whose default argument is true. The function should check to see if test key is in test dict. Okay, so if test key in test dict dot keys. Yep, so that's the first one. We can let's just check these off. That'll be a check. Oh, a check. Where is it? Oh, it's not going to let me put that in. Okay, let's do an X then. If the key is in the dictionary, if pop is true, so and if pop is true, so we need a condition to check for pop. So this will tell us under this if, inside this if will tell us, well, we can make the assumption that the key is in the dictionary, so we need to test if pop is true. If pop is true, the function should pop the value of the input dictionary and return it. Pop the value, this should probably say located at the test key located at test key of the input dictionary. Okay, and return it. Okay. So that's that, if that's true. If key is in test dict and pop is false, so if pop is false, let's see. So we need to check this as well. Where am I? Pop is false. The function should simply remove the key value pair from the dictionary. If test key is not in the dictionary, the function should return a string that says key not found. Okay, so that's the alternate to this condition. So since that's just the alternate, we can do an else here, and we'll return key not found. So let's just have a few tests here. So this one is a little bit strange because I'm assuming it's actually asking us to cause a mutation to the input. I might be wrong about this. Let's see. The function should simply remove the key from the dictionary, return the altered dict without changing the input dict. So it may or may not be asking for this. Okay, so there's our edge case. So let's think of some tests. Let's test each of these scenarios. Let's do d equals, and I'm going to assume the immutability route. I'm going to assume this for now, that we want that to be immutable, i.e. not alter its input. If that doesn't pass the test and learn, then we'll do it the mutable route. Okay, so we'll just say d equals a key of, let's do a 50, b 25, c hello. I don't know. So let's do a print, try to remove. Okay, we'll try to remove from D. We'll take in test key, which will just be C, and we'll say pop, or excuse me, pop equals false. We'll do that. So that'll be, or here, I'll do this, true. I'll do true first. Okay, so in this case, I'm expecting to return, I think, the item that got popped, right? So if popped is true, the function should pop the value located at test dict of the input dictionary and return it. Okay, cool. So first of all, I'll do the copy approach. We'll just say test dict equals testdict.copy, and that'll be our immutable approach. And like I said, if that doesn't work, we'll do the mutable approach. Okay, so this is this. So in this case, we don't need to capture this in a variable. We can just return it straight away. And let's turn this actually into a condition. Since a condition is just any expression that returns true or false, including true and false, right? This is a variable that either holds true or false, so we can just say if pop. And did this say popped or pop? I think you said pop. Yeah, pop. Okay, so if pop, return dict.pop, else return the dictionary with the key removed. So I think what we want to do is just return test dict after we pop it, like this. Okay. And let's just, I said I would make test cases and then I got distracted, didn't I? So for this first one where pop is true, we'll do pop is false here. And then, see, that's something. I want to do this. Uh-oh. Is OBS giving me a problem? I just got a notification from OBS. I'm not sure what that's about. Okay, well, okay, it's not telling me. Cool. Sorry about that. Just getting a message on my computer. Okay, let's do this. So let's try something different with the keys as well. Oh my gosh, I'm swimming. My eyes are swimming through this stuff. So for this one, we expect this dictionary, but we wanted the pop, so we want to pop the value here. So we should actually expect just the value to be returned. Or is it the whole key value pair? Kind of think it's just the value. Well, anyways, I guess we'll find out. And then, to be honest, I don't use pop much with dictionaries, as it shows a little bit. I have to like figure it out again every time. So with this one, we expect sort of the opposite. We expect sort of the negative case of that, which is just that C is removed. And then for these two, I'm going to do, these are kind of our edge cases, A, B, C, D. We're going to see if D is in there. For these two, I expect key not found. And the reason I'm doing this twice is because I want to see if, you know, I know the way that I wrote my code, this isn't going to happen, but for the sake of good testing, right, what if changing pop to true would, or false, would mean that we'd get a different result even if the key wasn't in the dictionary, right? So we're just testing it under multiple scenarios to make sure that we're actually getting a true positive. It's like, what's the opposite of a false positive? A true positive. Okay, cool. So are we going to run our code? Okay, cool. So we get key not found, hello, and then the dictionary. So it does look like we just get the key. So that's what we expected. Okay. Oops. Cool. Correct. All right. Hopefully that was helpful. So it looks like this was, this question might be able to use a little bit of clarification because oh, where does it say it? The part about function should pop the value of the input dictionary and return it. This the should simply remove that key value pair from the dictionary. So those two statements about removing from the input dictionary or removing from the dictionary kind of lead you to believe that it wants you to actually operate on the dictionary past in a way that would mutate the dictionary outside of the scope of the function, right? So um, in this case, I'm copying to prevent that because I'm just going to go ahead and say it is universally a bad idea to take in a mutable type into a function and then alter the type such that the type that change is reflected, that mutation happens outside of the function. So we don't want to we don't want this dictionary to go in to the function and then have the function just change it. If I print the dictionary, oops, if I print the dictionary after any of these, I want to make sure that it's the same dictionary that I passed. That's the preferred pattern. An anti-pattern would be that the function takes in the dictionary and then I print out the dictionary and the dictionary is changed according to what was popped from the function. So I'm copying to prevent that from happening. I kind of feel like, well, let's just test this out. I feel like this will pass either way. Yeah, so this will pass either way, actually, whether this function causes a mutation in its input or not. But it is universally a good idea to copy a mutable type that you intend to cause some alteration to. That way, you're causing that alteration, you're causing that mutation on a local type, and then maybe you want to return it, right? So that's a much preferred pattern. Cool. Looks like we have a follow-up. I was confused about why pop is an argument. I was thinking that it would be passed into it. Why pop is an argument. Yeah, I think this name this name is honestly a little silly. I almost would call this like should pop or something like that. Can't you use pop? Yeah, it's just like it sort of makes it sound like it's being conflated with with like the the method called pop, right? And it does tell you whether or not you're going to use the pop method. Of course, I'm doing using the pop method in both cases. I'm just either returning the thing that pop returns, or I'm popping and then returning the dictionary after it's been popped, right? But yeah, almost think like renaming it kind of makes a little more sense in this particular case. This is an interesting one. To me, this kind of thing, like if I call something count, like count equals 0, and this is something that you do because you like to count stuff, right? Where it's often useful to count things. But right, there's like a list dot count method, and this sort of to me feels wrong, even though it's not. Same thing with like pop, right, where we have list dot pop and dictionary dot pop, right? This isn't the same as calling something len or sum. These are functions that will get overwritten if you have a variable called len or sum. Pop and count are methods that only, excuse me, gosh, sorry, they only exist as properties methods of the types in which to which they apply, right? So count applies to list, count applies to strings, tuples. I don't know about sets. No, of course it doesn't apply to sets. Sorry. Count applies to lists, strings, and tuples. And it only exists as a property to those things, right? So, calling something count or calling something pop might seem like, oh, well, that's like somehow directly related to the method itself, but in this case, it's literally just a variable name. We could call this, like I said, we could call this should pop, or we could call it poodle face or something. So it just happens that they used pop, and that makes it seem, I think, kind of confusing. Okay. Hopefully that helps. All right. On to the next one. All right. I'm not seeing another question. I mean, anybody, feel free if you have any follow-up questions to that. Yeah, sure thing. Yeah, so if anybody's got any follow-up questions, that's fine too. For now, I'm not seeing anything, so yeah, I think I'll just put a minute on the clock. Give you all a second if anybody's got a question to bring it in. And if I don't see anything, I'll just go through the material. Okay, let's go through the material. And if anybody's got anything, feel free to put it in there. I'm starting to sound a little bit like a broken record. Oh, no, here we go. Here's some accessing dict values challenge 2. This is, where is it? Accessing dict values challenge 2. Check dict. Okay. Write a function called check dict. Takes 2 arguments. A dictionary, first argument. Okay. A potential key to that dictionary, second argument. If the key is in the dictionary, sounds like an if statement to me, the function will return, we'll just delete the return its value, the value located at that key in the dict. If the key is not in the dictionary, sounds like an else. My notes inevitably just become Python. Okay, so the function should return the string. That key is not in the dictionary. Okay. Return. All right. And let's see that code. I'll copy that code in. Okay, if possible key in dict.keys return, there it is. That key isn't in the dictionary. So possible key, this is just a parameter name. We want the value located at, in this dictionary, located at possible key. So we want to do d sub dictionary sub possible key. Like that. Voila. And let's see about this. If the key is in the dictionary, the function will return its value. So that's a little bit confusing as well. Like, I think it's kind of funny. Like, I know what it means. Like, the keys, the corresponding value to that key in that dictionary. So that could be clarified a little bit. But yeah, there's a way of interpreting this in which the code that was sent in, adheres to that interpretation. But yeah, that's a little bit weird. So a little takeaway here that I'd suggest is that that key value pair language can, honestly, it feels always a little clunky. You just kind of get used to it. You just kind of have to get used to that association kind of constantly being made and implicit in a way. So yeah, but you were definitely almost right there. Cool. Yeah, it's always like little things like that that are just hidden right under your nose. Cool. I'm going to go ahead and jump into the material, and we can go from there. Okay. Oh, what? Oh, okay. It's going to reload the page. Wait for that. All right. String properties. So for this lesson, we want to understand some fundamental properties of strings, understand some key differences between strings and other sequences. So strings are sequences. Recall from earlier that strings are sequences in Python, but they are also immutable. So there are two immutable sequences in Python: strings and tuples. Tuples are also another immutable sequence. Sequence just means it's a group of things. I'm not sure if dictionaries and sets are considered sequences. I think they aren't because they aren't ordered. I think a sequence is necessarily implies a collection that has an order that is maintained, right? And all that means is that, you know, if I put in the characters in order like A, B, C, D, that there's no scenario in which that would be treated as B, C, D, A or something. With a set or a dictionary, ordering is recently kind of changed in terms of like the way they're printed out or iterated through. And I think there's some other like significantly different kind of change about there being sort of consistency in the terms of the way they're iterated through. I'm not entirely clear on how all that has changed. Those changes are fairly recent. Um, Regardless, we don't think about, even though, you know, it can appear sometimes that an order is maintained with those types, we don't think about those types as having an order. We don't think about dictionaries and sets as having an order. It's I always use this analogy of like a jar of jelly beans. There's no third jelly bean in the jar. It's just they're all equally in the jar, and their position is irrelevant. It's not a meaningful part of their membership in that series, or in that collection, right? So strings are ordered. They do have a numbered index associated with each character. So that's what that means. Immutable means that they don't have any methods that will cause a change in the object. Whenever immutability comes up, I like to just give it a little airtime because it's kind of a funky topic and it's one that's worth understanding, right? So if I have a list equals to a list, and we go list.append, hey, print list before and after. This is not surprising, right? So this is lists are mutable. This is a mutation to the list. It caused a change in the list, right? And I can prove this. This object changed its value, but it's still literally the same object. And when I say literally, I mean quite like really actually in your computer's memory, in your RAM, where this program is running, there are some bytes which represent the data held by this list. Those bytes, um, like the buffer in which those bytes exist, grew, right? It didn't go get a different set of bytes with a different ID associated to that set of bytes with the new value also in it, right? That would be an immutable operation. What this did is it took that set of bytes and it added something to it, right? And like, so that set of bytes has an ID associated with it, and it's literally altering that part of the memory for this, rather than like copying it and making some changes, right? Which is more immutable behavior. So let's look at a string. Hey, let's do string equals hey, and we'll print string, and I'll say string dot upper. Now, if you know what the upper method does, it transforms all the letters in a string to uppercase. So if this were mutable, you might expect the behavior that if uppercase were a mutable method, you might expect the behavior that we have a lowercase version of HEY and then an uppercase version of HEY. So let's check this out. So it's the lowercase version in either case. So what this is saying, when we say a type is immutable, it means that none of its methods or operations will ever be able to cause a change in the same way as a mutable type, right? I was actually gonna prove this thing about mutability by printing out the ID. Let me do that. Here, let's do the ID followed by the value. Let's do that. And then let's do that for the string as well. Oh no. Okay. So now we'll see their IDs as well. Okay, so if you notice, it's a little small here, but let's just paste this in, right? The value of the list changed, but the ID stayed the same. That tells me in my memory, in my computer's, my program's memory, that in the literal RAM on my machine that's allocated to running this program, this list exists as the same object. It exists as exactly the same list, right? So we just took the same list and changed it. If we look at our string, of course, no change was made, right? Right. But if we print out our upper here, this is where things get interesting. We'll print string.upper, and let's do the ID of that as well. I know I'm going a little bit fast here. I know I've covered mutability before, but it's just it's an important enough, like I said, it's an important enough topic that it's always, to me, whenever it comes up in our material, it's always worth just giving a little bit of airtime to, because I don't know, for me when I was learning, it was just something that I needed to like have shown and demonstrated to me multiple times before I was like, oh, mutability just bears on whether we're altering an object in place or whether we're making a copy with changes, right? So immutability means if it changes, you get a changed copy back that's actually a different object. Mutability means you can make the change in place. So if we look at the ID here for hey, we can see that this is different. This is a different object. So the value changed and the object changed, right? So that's the sort of the signature of mutability. The cool thing about immutable types, and you know, if I have to pick something, if I have a choice between using something that's mutable versus using something that's immutable, I'm usually going to pick a, you know, all other things being equal for a given problem, I'm usually going to pick an immutable type, which might seem like, okay, well, you know, mutability has this sort of this power that immutability doesn't have, which is true. But let's just look at this. I can recuperate the behavior of mutability kind of like this, right? I can just say, well, string equals itself in its uppercase form. And this is going to give me a different object. I mean, sure, its value changes, but like, that's kind of like, it's kind of like having a mutable string.upper method, right? So yeah, that's kind of a nice thing about immutable types, is that, sorry, uh, we can actually usually mimic all the behavior of mutability through various means. And this is a very simple example, but there's like a thing where you can use concatenation, slicing, and indexing for tuples and strings to mimic all of the mutable methods for lists, which is pretty cool. The advantage, and it's like, you might think, okay, well, you can recuperate that behavior. That's good to know. So maybe immutable types aren't as compromised by lacking mutability as you once thought. But like, still, why duplicate it in memory? The reason it's often worth duplicating things is if the memory footprint isn't going to be significantly impacted by that duplication, you can kind of rest assured that your data isn't going to change in a way that you didn't predict. So mutability, if you sort of use mutable behavior carelessly, or without being aware that it can change data out from under you in a way that you didn't expect. So yeah, that's a thing that can happen that you just have to be aware of. Okay, cool. So we've made it this far into the part about strings. Okay, so what all that means, what it means that it's a sequence, it's ordered and immutable, as I just described. This means it can be iterated through, sliced, for example, but do not support indexed reassignment or the del statement. So we can't use del or indexed reassignment or del to alter specific characters at a given index. This is often called item reassignment or item deletion in lists. So lists will support this, but that is a mutable behavior. Excuse me. Okay. So this string is really just a sequence of individual characters. Print list of the string. This would just print, well, it'd be easier if I show you. I'm trying to get out of the habit of like describing code in general, because I realize this thing like where people will say, oh, I wrote code that likes it, and they'll like read me the code, and I'm like I have no idea what that was. So I always need to see it and see what it does, so that's what that's going to do. It's just going to give me a list with each individual character as its own distinct element in the list. Notice even the spaces are their own elements in the list. Containment. Similar to the list type, you can check if a character is contained in a string by using the in keyword. So this is a check for membership. So P in Python, right? So yeah. So all of these examples would be true, right? So capital P is in Python. Let's check this out though, right? We know that's going to be true. What about lowercase p? I mean, I'm asking in a very leading way, so you can probably anticipate the answer. Well, let's just look at that. So capital P is in Python. Oh, it's taking forever to run. Okay. And then lowercase p is not in Python written with an uppercase p. Of course, if I rewrite Python to use a lowercase p, then it is in there, right? So when you do a check for membership, again, this is, some of you might hear me talk about like understanding types by understanding which operations apply to those types, right? So in is a good example of this. In is an operation. You can think about in, it doesn't visually look like a function. It doesn't remind us of a function looking at it, but it's very much like a function in that, look, here's some inputs. And when this process executes, it yields a value back, much like a return. It very much returns a value. And that value has a consistent type that we can rely on, which is generally how we want to write our functions, right? So in this case, in is an operator that, it in this case takes a string as its arguments and checks if the right-hand argument is, or the left-hand argument is a member of the right-hand argument, and returns a bool, true or false, as to whether it is or not, right? So Yeah, it's something good to remember. So this will always render true or false. Okay. These will also be true. I suppose it might be worth mentioning this one as well, right? It might not seem like this would be true, but this is going to just check if any substring, so transistor with the IS right there. So IS is a member of transistor. So for char in alphabet, print char, we can iterate through strings. This is just going to print each character. Something that I've noticed, I always take this for granted, that we can just iterate through a string. I presume that, like at this point, if you're at this point and learn and, like you're able to follow along with this material, that this would make sense at this point. But I have noticed some people in problems where, it's iterating through a string is useful. Recently seem not to know this one. So sometimes I'll see people like cast this as a list, or try to do like dot split or something. Yeah, and that's not necessary. You can just iterate straight through the string if you want to. And yeah, like I said, notice I get each character individually if I do this. Also, this would actually be exactly the same behavior if I cast this as a list like that, but we just don't need to go through that step. They also support the len function, so we get the length of a string by using the len function. They also support the count method. I always think len and count kind of go together. It makes sense to talk about them together. So if I say hello dot count L and hello dot count Z, right? So there's going to be 2 L's in hello, and there's going to be 0 Z's in hello. Slicing. This is a good little, it's a pretty decent little cheat sheet here. I always write my slices, no matter what I'm slicing, I always put both colons in. You'll usually see it this way, though, with if you're using only start and or stop portions of the slice. You'll usually see it with just one colon, but I always end up putting both colons in just because that's what I prefer. Yeah, slicing, I won't get too deep into slicing. Slicing is a mechanic that is in Python that is available for strings. You slice by the index, and that'll give you the characters, within the range of the being described by the slice. So this would say to start at index 3, which is really the 4th character in the list, right? Index 0, 1, 2, 3. Index 3 is the 4th character. Stop goes up to the 7th index in this example. Stop, like the stop parameter in a range, is excluded. So this will go up to and just short of stop. So this will start at the beginning and include everything up to element 6. Since we're starting at 0, 0, 1, 2, 3, 4, 5, 6 is 7 elements, though. So this is a way to get the first 7 elements. Yeah. start, stop. The third portion after the second colon is the step. So yeah, this will step in steps of 2, so you'll get every other character that way. So yeah, slicing is a very, very powerful mechanic that's worth putting some time and energy into becoming good at, because yeah, you can really do a lot with it. A quick and easy way of reversing a string: ::(-1), a slice of : ::(-1). So this is basically saying, we have start, stop, step. If I don't provide something for start and stop, it's just going to start at the beginning, stop at the end, and it's going to go in steps of -1, which means if I start at the beginning and I go in steps of -1, my first element is actually the last element, and then a step of -1 is the second to last element, and another step of -1 is the third to last, then the fourth to last, then the fifth to last. So this effectively, : ::(-1), it effectively reverses any sliceable collection, right? So you can reverse a string, you can reverse a list or a tuple this way, and it's really handy. I'll just demonstrate that, and we'll see the reverse version of that. This is talking about the dot split method. Let's see, and casting. So slicing with strings wraps around. Well, it wraps around, but only that one time. It won't like keep wrapping around, right? So if I have so this, what you're referring to is like wrapping around in that case, is true about any sliceable type, not just with strings. But since you asked, let's just look at this. GLO. So if I slice hello at : ::(-1), we get ole. So it won't, how do I say this? It won't it won't keep going. It sees, how do I put this? It sort of sees this as the valid, like, sliceable space, if that makes any sense. Like, you can slice once forward and once backwards, but in either case, you like reach a terminal point of the list, or of the sequence where it stops, and it'll stop there. This is talking about casting a list as a string. It's kind of interesting behavior, right? It literally just, it puts the list into a string format just by putting quotes around it. You get the square brackets, the commas, and everything. So one thing, idiomatic formatting of lists requires, in Python, is structured like, well, we have our brackets, obviously, to delimit the beginning and end of the list. Then we have an element, comma, and then a space. The space is not meaningful to the way this is going to be cast as a list. It's just like, it's automatically going to format it in the idiomatically Pythonic way, right? So if I kind of mess up the spacing on this, I've taken it out and I've added too much of it here, whatever, I've left it in there, this is still going to format with a single space between each element, between the comma and then the next element. So just like that, it's going to format it, the string version of it, in the idiomatic way. I can't say. It's funny. I know I have done this. I have cast lists as strings and then manipulated those strings. I can't think of why. I can't think of a reason to do that. It's like one of those things like where in the middle of a problem I'm like, "Oh, this makes sense." But like I can't remember the specific problems or think of like a reason or a time that you should do this. Um, and I'm skeptical of, now that I think about it and I'm not able to justify it, I'm skeptical of if the way I solved those problems in the past was really the best way. So can't say that casting a string or a list to a string in this way really comes up that much, but if you happen to do it, just know that the spaces are going to get auto formatted in this particular way. So. Huh. Okay. Oh yeah, this is an interesting example. If we have a set of characters in a string that expresses a number that Python would otherwise see as a valid integer or a valid float, we can cast it to the appropriate type. So this will work. I don't believe this will work though. I think that'll give me an error. Yeah, so if I have a float string here, try to cast it as an int, that'll give me an error. I believe I can cast it to a float though. Yes, I can. And then I think, I don't know if I can cast an int string to a float. Oh, I guess I can. Okay. So yeah, this is kind of the thing. Like one of the really handy things about strings is that like every type basically has a textual reference, like a way that it's represented in text. So essentially, everything can be translated to strings. Huh. If you want an interesting, you know, example of how central and important strings are in programming, right? Look at this document. How do you think the Python interpreter sees this, lib.py document? Well, initially it sees it as a document which contains a string of characters that it will then parse um, into a uh, list of tokens, and then into an abstract syntax tree, and then eventually be able to convert that string into runnable, executable code commands, right? So, every text document to an interpreter or a compiler is just a string, right? So, it's a really central type in programming. Remember when I realized that, it was just kind of a mind-blowing moment. Okay, cool. I feel like I'm being very silly talking about strings for so long, but I don't know, I like my strings. All right, so true or false, what is the result of the following Boolean expression? List of string of this list equal to um, this list. You might hope that Python would be smart enough, I mean, it can look at a number and be like, oh, well, that's a number. I can cast that, those digit characters as a number. But let's print this out. It's just going to do what this usually does, what this would do, exactly the same thing it would do with any other string, any other characters, right? it's going to make each character in the string, including the square brackets, including the commas, including the spaces, everything, into its own element in the list. So these two lists will not be equivalent, so that's false. We got somebody whose mind is getting blown by like strings being the thing, right? Yeah, there's no magic to this whole text document, just a string. Whole thing's just a string. It doesn't matter if it's like it doesn't matter, as long as it is a text document, right? Like if it's a JPEG, like that's not textual information, right? But any text document, whether it's like CPP for C++ or .py for Python or .js for JavaScript, like at the end of the day, they're all strings. So pretty cool, right? All right. Write a function called char count. Okay. I'm just gonna do this here. Def. I'm breaking my own rule. Um, I'm breaking the rule that I always say about like work in your own environment rather than in learn and write tests first. I'm just gonna just do it in here. I do this a lot on stream and then end up regretting it, but that's okay. Whatever. I seem to not care at the moment, so it'll take in 2 arguments, a string and a character. The function should return the number of times. Let's see if that works. Okay, cool. So this is just a wrapper for string.count. Number of times the given character appears in the string. Okay, cool. So we could do it like this, the very easy way, but just as a plug for the accumulator pattern, just to show that it can do just about anything, right? We can say for C in string if C equals ch count plus equals 1, return count, and that'll work too. Remember, if you're good at accumulators, if you know your accumulators and you don't know like some special tailored built-in way of doing something, you probably just do it with an accumulator. Geez, it seems like more often than not. There's a lot of things where I'm like, oh, I'll just write an accumulator for this. And then later I learn that there's a built-in tool. And then I'm like, oh, I guess I'll just, now that I know that there's a tool for that, I can learn the tool. But it's just a plug for getting good at accumulators because they fill in the gaps of everything else that you don't know yet. Nearly everything else. Okay, write a function called Isnumber, which takes a string as an argument and returns the type as a string if the string is indeed a number and the string not a number. Okay, let's just do this. Not a number. I don't trust it. I'm going to copy it. Copy that right there. Okay. Otherwise, so if the string is a number, return type enter float. Okay, so we just need to be able to look at this string and determine this. So, hey, what's going on? Oh, right, I can't. I'm trying to use a shortcut that learn doesn't support. Well, all right, I'll do it the right way. Okay. So let's do this. Whoop. There's our tests. I'll just retype this. Def is number takes in. I'm actually just going to call this text, and we'll return return let's have one for int too, since that's not being represented here. So let's do 3. Here we have a number, that is not a float. It's all valid numeric characters, but it's just got 2 dots in it, so that can't be a float. So that's also going to be not a number. Okay, so we should see int, float, not a number, and not a number. Okay. I'm actually just going to do this. Bam. Okay, so there's my returns. And we'll just kind of code around these. Okay, so first of all, let's see. We can't use .isDigit. I'm thinking of an elegant way to do this. Oh, screw it. I'll just do the brute force way. So for C in text, if C not in, and I'm just going to do a string of dot and then all the valid number characters. So that's going to be, I'll do 0 up here, just I feel better about that. So dot, because dot is a valid character for a float, right? So if C is not a number or a period, then we know we can return not a number. Elif, no, we don't need an elif, we need if text.count period is, let's see, is equal to 1, yeah, then we know it's a float, else it's an int. Okay. We have another scenario where we need to return not a number. I'm just going to treat this like an edge case. We're going to say if, actually it'll be just this line, if text.count dot is greater than 1, then we know it's not a number, right? Like if we can already determine that it's not a number if there's 2 periods in it or more, and it's not a number. Otherwise we can iterate through and make sure every character in there is either a dot or a numeric character, and if we find one that's not, we'll return not a number. Then here we'll just count the dots again, and if it's equal to 1, then we know it's a float. We know it's not going to be greater than 1 because we already determined that here. So we can count on that not being greater than 1 here. If I thought about this, I feel like I could kind of pare this down. I mean, I know I could get rid of this else and back this out, and that would work the same. But I don't know, either 6 and 1/2 a dozen of the other. I think there's a slightly maybe more optimized or cleaner way of doing that. Maybe I could get rid of a condition in there, but I don't know. Not too worried about it. Working code. Nope, not working code. That's great. Oh, we got int instead of not a number. Interesting. Oh, well, look at that. So it looks like I got an empty string. I didn't even think to test empty string, but empty string is definitely not an integer. It's definitely not a number. So let's do this. Let's see what happens with empty string here. Well, we know what happens. We know what we expect, but this is giving us int instead of not a number. So let's see why that is. Well, actually, I don't really care why. I'm just going to say or text equals empty string, then return not a number. Okay. Oh, now I'm curious why, though. No, we're just going to do this. I guess it's fairly obvious. You know, if the string is empty, then the count is less than 1. All the characters, you know, we do for C in text, which means there's nothing in the text, so the for loop doesn't even execute. We don't even have a character to check, so the for loop just gets ignored and everything in it. Then we check if the dots, which there are no characters, there's no dots, it's equal to 1, that's false. There's no dots in there, so it just returns an int. That's why that happens. So looks like we'll just handle that separately and that'll work fine. Let's see what the suggested solution was. Oh, if not string, so it looks like this is like virtually the same solution. Ooh, there's an error in the solution, I think. Could it be? Let's just see real quick. I think it has string or int and float reversed. Yeah, look at that. String.count. This is like exactly the same as my solution. Yep. Oh my gosh, they even put the numbers in the same order. This is checking the same condition, albeit in a slightly different way. I'm saying text equals empty string, which is what I prefer to do. This is using like Boolean inference. So if not string, a string can be interpreted as a Boolean value in certain contexts. In this case, it can be if you put it in a in a condition portion of an if or an elif, it can be inferred as a Boolean. So not string. So if the string is empty, it's going to be seen as false. So not false is true, which will gate this function and return not a number. But it's the same. It's a different way of doing exactly what I'm doing here. If text equals empty string, I prefer this because to me this is, I don't know. I like to be explicit even if I know what the other way means. I like to just like be very explicit in my code. So it's a personal preference. So I believe, yeah, text.count equals 1. So this should, oh, this is seeing if it's equal to 0. Oh, okay, I thought this was doing like I was doing if it equals 1, but yeah. So this says basically if there are no dots in the string, then it's an integer. And I just realized I could totally like think about this as if dot in text like this. Since I know that there's either 1 or 0 dots, and I know that because I already counted them up here. I don't know. It's kind of a meaningless difference, but I don't know. I like it. Cool. I know I'm kind of going into depth on each of these. I'm kidding. I have fun like with these. I know they're simple problems, but I like kind of getting into the theory of things. So let's see, we've got something. Oh yeah. Somebody's saying it, they have a comment about this is honestly the reason, since most of the coding that I do is like literally coding for coding's sake to teach other people coding. At this point, like my coding style errs more and more towards the explicit. But the funny thing is, like, doing that, I find myself just actually genuinely preferring it that way more. But yeah, I like this. I like teaching this way. But yeah, you will see this way. Um, you will see it using Boolean inference, or sometimes called truthiness or falsiness, right? So an empty string is falsy, and a string with content in it that's not empty is truthy. There, that's true for any sequence or any collection type. If it's empty, it's falsy. If it's full, it's truthy. For numbers, if they're zero, they're falsy. If they're not zero, they're truthy. So if they're negative, they're truthy too, which is kind of a weird one. Anyways. Excuse me. By the end of this lesson, you'll be able to use string.join method to concatenate lists. Oh, we didn't talk about split. It mentioned split back there, but we didn't talk about it. Good thing this next portion is entitled split and join, because boy, are those two extremely important. I mean, they're important enough to have their own thing on, so it's not that big a deal that I missed them because more time. Okay. So split and join. We've got about 10 minutes left. If you have a question that you want, I will take that. I'm happy to take that. I think we have time for one more. Yeah, so get that in now, and I can get into that. But this is kind of a big topic, so was it big? I don't know that it's that big. It's just important. Split and join. If you know two string methods, these are kind of the ones. Maybe if you know three, maybe lower is the other one, and count is 4, and all the other good ones to know. Anyways, split and join are very important. So let's do let's come in here and pick my so I have this notes document. I suggest that everybody do this. This is like every time I do a study hall, anything, or just like if I'm just coding on my own, and which I do, I'll just like play around and solve little problems, or like do my finances or whatever, and like I'll just pop it in here, and you can see like I'm up to 13,000 lines of code here. So, and I've got just all sorts of like little tools, little notes. This is not the only file like this I have. I actually usually retire them when they get around 10,000. So this one's ripe and needs to be retired, but I'm literally too lazy to copy it and make an empty one, evidently. So it's nice. Do this, and you can just have like it's like a palette where you can like, it's like a painter's palette. You can go take a little piece of code, like, oh, I did this a few weeks ago, and you can go take a little piece from that. And I keep little useful tidbits. So when I want to do like text processing stuff, I've got a little bit of text to process that I know just gives me enough variation and enough similarity that I can kind of have fun processing it. So this is just a little Robert Frost poem. I don't have any special attachment to this poem. It just works well for text processing stuff. So that's why I keep it around. Okay, so let's just print text. Probably not going to be that surprising. Nothing mind-numbing or mind-blowing about that. So split. Remember we talked about. Is this ever going to print? Okay, there we go. So that's what it printed out. It just printed out just what you see there. We talked about casting a string to a list. I think there are times when I've done that, like used the list function to like actually cast a string to list. There's a time and a place for that, but more often when I need a list form of a string, I need to break it up according to some pattern in the string, right? Like maybe I need every word in the string. This is a really common one, right? So words list. I can convert this string into a list of words by saying words list, just any variable name. Words list equals text dot split. And if we can give split an argument, but if I don't give it an argument, it's going to split on spaces. So let's see exactly what I mean by that. So what it's going to do is it's going to go through, since I didn't give it an argument and it's going to assume to split on white space, it's going to, every time it encounters a white space character, right, here's a space, it's going to make everything in between those white spaces its own element in the list, right? So actually this is the, shoot, I should have got this one has punctuation. That's why I have two of them in here. One of them has punctuation, the other one doesn't. I'll use the punctuation one. There's the punctuation one. So this gives me words, and same thing for the punctuation one, by the way. It'll give me words. The punctuation will be in the word in which it is contiguous to, as delimited by white space, right? So lovely right here with a comma at the end will have the comma at the end because it's delimited by white space on either side. But let's say I want to split this into sentences. I can split on dot. So this is the cool thing. Split is such a cool method because it actually kind of makes you think about the way you read. You're actually doing something very much like a split, right? Like I can look through here and I can make a list of sentences. I'm not talking about a Python list. I'm just talking about like a regular, I could make a list of sentences based on where the dots are, right? The way I would do that is I would go through, I would read until I saw a dot, and I'm like, okay, well, everything before that dot is a sentence, and everything after that dot, between that dot and the next dot, is the next sentence, and so on and so forth, right? So, and that's how we literally make sentences, is just finding the periods and stuff, right? Might be a little different when we add in question marks, things like that. There's ways around that, but this is a simple example. So if I wanted to do this is no longer a words list. This is a sentences. I probably spelled sentences wrong. It's kind of ironic, but whatever. I'm not going to worry about it. Sentences list is going to be this list of sentences. This is a little bit small, so let's copy that in and actually kind of prove what I'm saying here, right? So let's break it out where it's actually making new elements. So if I look at this, right, this is a new element in my list, and then here's another new element in the list, and then looks like here's another. Try not to miss any. Here's another, and if we go through, we'll see that these are the this is each element in the list is now a string. It's now a complete sentence as delimited by each period in the string before. The way to handle, if I wanted to, a question is a sentence. It's just not a statement. It's a question. So if I want to handle question marks as valid sentences as well, I could do text dot replace and I could replace question marks with periods, which is not going to preserve the fact that they're a question, but it will correctly now delimit sentences, grammatical sentences, on question marks and periods. So that's kind of a way around that, right? If you want to split on multiple things, you can kind of chain a bunch of replaces together and sort of unify the thing. Sometimes you might have a special character like splitty thingy. We could replace all the question marks with that, right? And then I know I have this distinct handle on which we could replace all the periods with splitty thingy, and we have this distinct handle on which we know we can split. Brings me to another point about split. Won't worry about the whole thing about replace. That was a bit of a tangent. If that's not landing for you, don't worry about it. Yeah, just focus on this for now with split. Another thing about split is, notice how in the split, when I split on periods, the elements in the list there are no periods anywhere. So the thing being split is removed, right? And if I split on white space again, each element in the list, notice it's a single word, and that word may contain a punctuation character. It may or may not be capitalized, whatever. It may not be a pure word yet. We might need to clean the string first or something. But one thing there is not in any of these elements, which are words, is spaces. There are no spaces anywhere, and that's because we split on the spaces. So whatever character we're splitting on doesn't get represented in the end. In the list produced by the split. Okay, so often when you split, you're often going to want to rejoin that string, that list back into a string. So if you have a list of strings, you can, or let's say text again. Text again equals words list dot join. Oops, I did this wrong. It's not words list dot join. Excuse me, ignore that. That was a mistake. This is weird. Okay. I'm even used to this, and it still feels a little weird. We almost always call join on a string literal. This is a string literal. Literal just means, a literal type means it is literally the value that's typed, right? So quotes with a space in it is a string literal. Text again, right? This is a variable that expresses a string value, but it's not a string literal, right? So it's a little weird, but we almost always call join on a string literal. This, whatever the contents of this string are, will be the separator, the delimiter of each element in the list. So, in join here, this is sort of, this is the thing that we want to add as the separator into the string. Whereas with split, if we wanted to split on spaces or whatever, we'd put it there. If we wanted to split on dashes, we'd split it there. If we want to join everything back together with dashes as a separator, we put it there, right? So it's a little bit weird. So with split, we call split on a string we wish to split, and we pass a delimiter, and we get a list in return. With join, we call it on the delimiter string, we pass it the list we wish to join, and we get a string with the elements from the list separated by the delimiter string that we called it on. I know that's a lot. Something to remember, these are often when you use one, you'll end up using the other. Not always. Quite often you'll split a string and then like rejoin it into a list and then rejoin that list into another string or something. These are both really important to know. They're central in a lot of text processing. Something that if you're learning these, you're probably going to try to do at some point is say, oh, well, I want to join this list. This is what I tried to do. Because join feels like it's a list method, and you'll join it with spaces. You know, like maybe it should be this way, but it's not. Join is not a list method. It is a string method. So we have to call join on the string that describes the delimiter that we want to use to delimit the elements in the list that we pass as an argument to join. The result of that is the joined string. So that's split and join in a nutshell. We'll pick back up from this one again next study hall. Split and join are important enough that I think it's worth going over them twice. I'll kind of try to breeze through it next Monday so we don't spend too much time on it. And then we'll go through the challenges. That puts us right about at time, our usual stop time for study hall. Thanks to everybody who participated. This is a fun one. Had a few questions. Thanks for everybody with the questions. I appreciate that. If you don't mind, go ahead and give the video a thumbs up if you liked it. I guess give it a thumbs down if you didn't like it. Yeah, and feel free to DM me if you have any questions, and I'll try to get back to you as soon as I can. I may or may not be around on the weekend. We'll see how I'm feeling. If you're in premium prep, tomorrow's the last day, I believe. So I'll be in there with Tovio will be leading class, but I'll be around to hang out and potentially help with questions at the end. And then we have another premium prep starting not this Monday. Let's see, where is it? But the next Monday, I believe. So if you're not in premium prep, or if you are in premium prep and you want to be included in the next one, that one will start. Oh my gosh. On, looks like the 12th. Yeah. So yeah, cool. Thank you, and you're welcome. To the person who said thank you. And yeah, I'll see you all around. I'll see you next study hall on Monday. Cool. Y'all have a good rest of your day. Bye-bye.